Example 6.3. A tiny physics 4C student who is only 3 centimeters tall stands 3 centimeters in front of lens 1. The distance between the focal point and the lens is 4 centimeters for both lenses. The lenses are separated by 8 centimeters. Draw a ray diagram for the situation. B, what are the image characteristics? And C, what is the distance between lens 2 and the image it produces of the tiny physics 4C student? So what I'm going to do here is that I'm going to draw a ray diagram for lens 1 and then do the calculations. To get the image details. And then I'm going to redo that for lens 2. So here I go. So the first thing I'm going to do, I'm going to deal with lens 1. So that means I'm going to do a ray diagram and calculations. So what I'm going to do here is that I note that the focal length is 4 centimeters for lens 1. But the second lens is a diverging lens, so that has to be negative 4 centimeters. So I already set up my lenses for my image here. So I'm going to draw them just like this here. So let me try to center them. And that looks pretty good to me. And what I'm going to do here is that I'm going to set the scale. So the scale is then going to say that 1 square is 2 centimeters. So what I'm seeing here is that I'm seeing this. It says that it stands 3 centimeters in front of the lens 1. So that means, here's what I find here. So that means that S1 is 3 centimeters in front of lens 1, but this is a converging lens, so that means here that this lens is going to produce a virtual image. So if I look at my object, so if this is 2 right here, right, that's going to be 2. This guy's going to be 4, so then my image is going to be right here. Not my image, but my object. So then this guy tells me that the distance from here to here is now S1. So here I go. So you gotta be careful here because note that I called that F2 right there, but this is also F1. So here I go now. So what I'm gonna do now is that I know this is a virtual image. So I'm gonna do this here. So I gotta go parallel to the axis. Okay, I'm gonna go parallel to the axis. And then it goes to the focal point. So if it goes through the focal point, then I'm going to follow it backwards. So then it goes through the focal point, but now I'm going to follow the ray back because it's inside the focal point. So this is my ray right there. Now my second ray is going to go directly through the center of the lens. So this ray goes right through here. But then I follow this ray back. And so what you're seeing here is where that ray meets here, with those two rays cross, it looks like it's going to cross about right here. I'm looking that this now is my image. So this is image 1, and you could see here is that this distance is S1 prime. So what it looks that S1 prime has to be outside of the focal point. So that means here I'm going to say that S1 prime has to be greater than 2F1. So by guessing this, remember that's going to be 4, 8. So it's got to, that means that S1 prime has to be greater than 8 centimeters. Let's see what the calculation says. So let's look for it. So I'm now, well, I should actually look at the magnification. So if I look at the magnification, it looks like it's greater than 3. So I'm going to say that the magnification of 1, so it looks like it's greater than 3 squares. So what do I say here? I'm going to say that that looks like it's about 3.2. And of course, it's going to be positive because it's an erect image. Those are a guess. That's a guess. So now, what do the calculations show? What do the calculations show? So here we go. So the calculations show this. I have two equations I got to calculate. I have the thin lens. Thin lens equation tells me that I have 1 over F1, and that's going to be 1 over S1 plus 1 over S1 prime. So now if I solve for S1 prime, this will then be S1 times F1, S1 minus F1, and then we know here that S1 is 3 centimeters, F1 is 4 centimeters. So if I plug in my numbers, this is going to be 3 times 4 divided by 3 minus 4, which then gives me minus 12 centimeters for S1 prime. So I know what that image is now. That. So note, that's greater than 8. So it looks like it's almost like 10-ish or 9-ish on the graph here. So then if I look at the magnification equation, here's what I see. I have M1, it's going to be minus N1, S1 prime, S1. So then if I just put in my numbers, this is going to be minus 12 divided by 3. This gives me about plus, it gives me plus 4 magnification. And so now I have this. So now if I look at my image characteristics, we could then see that the plus sign, that tells me that I have an erect virtual image. And then I have a magnification of plus 4, which means it has to be larger. Just like my ray diagram. So note that I was thinking 3.2, 4-ish. It looks like they're more or less in the ballpark. Now let's go to lens 2. So now we're on lens 2. And again, we'll do a ray diagram and calculations. So what we find now is that image 1 now becomes object 2 for lens 2. Since object 2 is outside 2f2, the image 2 should be close to the f2 focal point. So let's go draw this here. So here I modified my image a little bit so that you could, so that I could move a little bit faster here. So here's my ray diagram, and look what I've done here. I've added the location of the object, and of object 2, and I've labeled that as S2. So one of the things that we got to remember here is that they told us that the separation between here and here is 8 centimeters, which will become important here in a bit. But you know what? I'm not going to put it here because that's going to become a problem when I draw my ray diagrams. So what I'm going to do now is that let's draw the ray diagram first. So note, look at F2. So I'm looking at lens 2 here. So I got to go to lens 2. So I'm going to follow the focal point. I mean, follow the parallel ray. And then this guy diverges as if it was coming from F2. So then if I try to draw this, this guy's going to look like it's going out. But then if I follow it back, it appears as if it's coming from there. So that's my first, that's ray number 1. The other ray that we should be looking at is that this ray has to go through the center of the lens. So if I follow this ray, it looks like this. So where those rays cross tells us what image I'm seeing here. So now you could see that this guy is the image here. So this is our final image, and this will then be S2 prime. So what do I see here? So if I look at the image characteristics, we could clearly see that it's going to be erect, it's going to be smaller, and it's going to be virtual because it's on the left side of the lens. Of course it's going to be virtual. That is a diverging lens, f2. So now let's go look at this guy. So S2, remember every square is 2 centimeters. So I'm going to guess here that S2 prime looks like it's going to be about minus 3.5 centimeters, approximately. What about the magnification here? The magnification compared to object 2 here, this is 1, 2, 3. It looks like it's about a 1/6. So what's a 1/6 here? I don't know what a 1/6 is. It's probably about 20th or something, right? So it looks like it's about a 6. So I'm going to say that the magnification of 2 is going to be about, about a 6. That's what it looks like. So 6 is probably about, let's say 20%. It's smaller than 20%, but it's a guess. But that's what my images show. But look at the final magnification. So the total magnification should be M1 times M2. Now compare the orange one, which is object 1, to the this guy here, and it looks like it should be about a half. So now what we want to do here is that we want to go in and we see what the calculation shows. Okay, so what do the calculations show. So here we go. So then I got to do two calculations. So I got to be really careful here. I need to know that distance S2. So the object to distance must be calculated. So let's look at this thing. So now let's look. So the lenses are separated by 8 centimeters. But then object 2 here, or the image of the first lens, well, that's just the image of lens 1, but that's 12 centimeters. So this is 12 centimeters. So you could see that object 2 is located where? So you could see here that this tells you that S2 has to then be 12 plus 8. So it's going to be 20 centimeters from lens 2. So I now know my object distance, and with my focal length of minus 4 centimeters, I could now calculate the object distance and the magnification. So let's go do that. So then here I go. I'm going to start off with the thin lens equation. So if I look at the thin lens equation, it says that I have F2, S2, S2 prime. Now I'm going to solve for S2 prime. This guy should be S2 times F2, S2 minus F2. Plugging in my numbers here, this should give me 20 times minus 4, 20 minus minus 4, and I get a value of minus 3.33 centimeters. So this guy is my image location. How did that compare to what the ray diagram shows? Look at that, minus 3.5 versus, 3.33. That's pretty damn close. Now, let's look at the magnification. So if I look at the magnification, the magnification equation tells me that this guy has to be M2 minus S prime divided by S2. And so my numbers are then going to be minus 3.33. And then my object distance is 20. And I get 0.17. Look at that. That's nice because we were guessing that that's about 1/20th. And look what I got. I got 0.17. That's great here. So now let's look at our characteristics. Note, this is a plus sign. Plus sign tells me it's erect and it's virtual, which is exactly what we see. Then I see that I have this guy is 0.17, so that tells me it's smaller, which is exactly what we expected here. So now we could then summarize everything. So in summary, I then see that my final image, S2 prime, is minus 3.33 centimeters. Its total magnification that we calculated is M1, M2, and this will then be what 4 times 0.17, which then gives me 0.17 0.67. If I have 0, so this is the total magnification. So if I look at this guy, and if I compare that to my ray diagram, we were guessing that it was going to be about a half, and this is 0.67. So I'm saying this is pretty damn close, without it being super scaled.